The symbol for velocity is a v. Velocity, the equation is delta x over delta t. Delta x, the displacement, the change in position of an object, is position final minus position initial. What then is delta t? Rishabh? Okay, let's back up. So what I've told you here is we know delta x is position final minus position initial, or x final minus x initial. So my question, Rishabh, is what then is delta t equal to? He's not seeing it. Arjun, help him out. Arjun, you gotta do a little bit. Gotta give me a little bit more than this. Paper.
Changing time.
Sure, I agree. It's changing time. I'm looking for an equation. Yes, we could read it as the change time. Looking for an equation. Megan.
Q2 minus D1.
Ah, that would be talking about 2 and 1, which is not what we're talking about here. I agree if we were talking about 2 and 1, but that's not it. Tina.
Yeah,
What an F and I. You guys have this tendency to just say the letters and not what they stand for. It stands for the time final minus the time initial. I understand in your math class, oftentimes you'll use 1 and 2 to represent the initial and the final, but in this class, we generally do not do that. We'll do initial and final, and there will be times where we'll have like 3 or 4 or 7 points, and we'll identify them with numbers. But right now, we have final and initial. So, velocity equals change in position over change in time, or position final minus position initial divided by time final minus time initial. I put a box around that. Mike, what does that mean? Not quite. I'm not going to disagree with that, but that's not what it means.
You'll give them to us on the test, and we'll have to note there.
Do you have tests in this class?
Or quiz.
Quizzes on a quiz or final exam, and I did suggest that you keep track of all of the box equations. This is the second one. Let's see. So velocity is equal to displacement over time, and displacement has both direction and magnitude, which means that velocity has both magnitude, and direction. Just like displacement has both magnitude and direction. Let's do an example problem, page 44, practice problem number 1. Page 44, practice problem number 1. And what we're going to do here is, one of the issues with solving physics problems is to be able to translate the words from words into physics. So what we're going to do right now is Claire is going to read the problem, and I'm going to do the translation. For the next one and many more, you guys will get to do the translation. But this time, I will go through and do the translation for you. I'll probably ask the questions, but okay. Claire, if you could please read. And Claire, what I'm going to do is I'm going to ask you politely to stop, and I'd ask you to stop, and I'll write stuff down and ask you to go.
Heather and Matthew take 34 minutes to walk eastward along a straight road.
Please pause. 34 minutes is equal to something. What is it equal to, Ryan? Okay, this is part of the translation, right? We have the number here, 34 minutes. It's equal to, it needs to be equal to a variable. The question is what variable?
Initial time.
It is not the initial time, right? The initial time would be like 8:30 a.m. or something like that. Spencer? This is the change in that time, the time duration, right? It's not a specific time of day or anything like that, but this is the time duration, delta t. Claire?
To a store 2.0 kilometers away.
Okay, hold on. 2.0 kilometers is what? What is the symbol for that? Susan?
That's the displacement or distance. So delta.
That is the displacement. By considering its displacement, we are missing something. What are we missing? Trevor?
That direction, eastward.
Which is east. So it said it earlier, but we need to identify it here. The displacement is 2.0 kilometers east. Claire?
What is their average velocity in meters per second?
Okay, so now what I'm going to write is VAVG, so it's for average, and that is what we're looking for, so I'm going to put a question mark. And it said, Claire, was that in meters per second?
Yes.
Okay, so we're looking for the average velocity in meters per second. We have now listed all of our givens. What should we do next, please? Okay, sure.
Well, you use the equation is equal to change in position over change in time.
Thank you. We start with the first step here, or the next step, which is to write down the equation, which I'll write up here. The velocity equals the displacement over time, right? Next, Kishore. What do we do? That's okay. Arjun's got it. What do we do next? Okay, so one issue that we have is they've asked for it in meters per second. We have things in minutes and kilometers. We're actually going to do that as a part of this, so let's write it down first. We know that this is 2.0 kilometers on the top, and the time is 34 minutes. So yes, we need to convert this from kilometers per minute into meters per second. David, please do the conversions for us.
Well, we multiply 1,000 meters over 1 kilometer.
Hold up a second. So we know kilometers are going to cancel out. We're left with meters per minute.
And then, in order to change to seconds, we do 1 minute over 60 seconds.
1 minute divided by 60 seconds. Again, because 1 minute equals 60 seconds, minutes cancel out. We're left with meters on top, seconds on bottom, and the velocity is equal to. At this point, I hear the happy tapping calculator, doing the calculator calisthenics. When you got it, just let me know. 0.9803. Give me one more. 9?
Yeah.
Okay. 0.98093. Now, please give me the answer. What then is the answer to this question? Trevor.
Velocity equals 0.98 meters per second. East.
Thank you. So we have the correct number of sig figs, we have the dimensions, and we have the direction, because velocity has both magnitude and direction. Great.